So in this video, I will go over the common derivative rules of an exponential function. I will do examples of both bounded and unbounded integrals. So integrals of exponential functions. So exponential and logarithmic function. So here you have the derivative of an exponential function, right? You probably know this from taking the derivatives in calculus 1. So the derivative of a constant raised to a power is that constant raised to the whatever that power is times ln of a times f prime of x. So it's the base raised to the f of x, ln of a times f prime of x. Okay. And then if you have to take the derivative of e to f of x, that's going to be e to the f of x times ln of e times f prime of x equals f prime of x e to the f of x. And a good example would be like e to the x or e to the 2x, right? So your f of x is 2x, and then f prime is 2. So you just put the derivative or f prime in front of the e, so that's 2e to that 2x. Okay, 3, the derivative of a log base a of f of x is this formula, f prime of x over f of x over ln of a. So this is all review, nothing new. The derivative of ln of x is f prime of x over f of x of ln of e. So basically it's just f prime of x over f of x. Okay, now let's talk about integration rules. So remember, integration and derivatives are like they're like the opposite. You go backwards, right? So yeah. So let me show an example. So what I mean is, what do I really mean? I mean, for example, maybe you'll learn this in when you learn trig, trig derivatives. So for example, the derivative of sine of x is cosine of x, right? You haven't learned this, but you'll learn it in on the next section. So the derivative of sine of x is cosine of x. To find the integral, you go backwards. So the integral of cosine of x is, yes, you said it, sine of x. So that's how I think of integration. It's like uh, you just go backwards. Okay, so it's the same concept with this. Number one, the integration of a b raised to the x is a raised to the b of x over b of ln of a plus c. Or you can think of it as ab raised to the x over b ln of a plus c. Okay, go ahead and write that down. The integration of e to the bx, you could say as e raised to the bx over b ln of e, or it simplifies as e to the b of x over b plus c. So this is like u substitution. And yes, there is a section for integration using u substitution. And then the integration, you've probably seen this in the last video. The integration of 1 over x of d of x is ln of absolute value of x plus c. Okay. And then the fourth one, ln of x of d of x, is you kind of have to do, you get ln of x minus x plus c. And what they did was they took integration by parts. And you haven't learned that, but you will in the following videos. Okay, so go in and write these down. Do your integration rules, because we're going to use this. We're going to need these rules to do some examples. So in all of these examples, evaluate the integrals. So number one, we have the integration of 2 raised to the x of d of x, it is not bounded, right? There's no boundary, so you will have your final answer will have a plus c. Okay, so we have a constant raised to the x. So that is, we're going to use this rule. The integration of b raised to the x of d of x is a raised to the b of x over b of ln of a, right? So we got to find our a and we got to find our b. So our a is the base, so our a is 2, and my b is the number in front of x. So there's just no number, it's just an invisible one. Okay, and then just put it in the formula. So it's going to be 2 raised to the b of x, so that's 1x over b is 1 ln of a, which is 2, plus c. Okay, so that is going to be 1 times ln of 2 is just itself, so it's really 2 raised to the x over ln of 2 plus c. Okay, let's move on to example 2. So example 2 is 2 raised to 3x of d of x. So it's just like the rule. You just use the same rule from here because it's a constant raised to the x. So what is our base and what is our b? So our a is 2. My b is the number in front of x, so it's 3. So that's going to be, that is going to be a to the bx. So my base is 2 to the bx. My b is 3 to the x over b times ln of a. So b is 3 times ln of 2. And then there's no boundary, so you do have to add the plus c. Okay. Did you also know you can rewrite this? So if you look at your rules, you go back to your rules, this, you can also write it like this. So if you want to simplify this more, that's fine. So it would be a raised to the b, so our b is 3. We raise it to the x, and our x is just x all over b times ln of a. So b is 3, and then it's ln of 2 plus c. And what can we do? So whoops, our a is 2, so this should be 2. Okay, and then we know that 2 to the third is 8. And then on the bottom, it's just 3 ln of 2 plus c. And then according to your log rules, remember when you are expanding, if you have a number in front of the log or natural log, that's really a power. So you can also say 8 to the x, and then it would be ln of 2 to the third plus c. So that would be 8 raised to the x, and then that would be ln 2 to the third is 248. Let's see. Okay. Let's move on to 3. So same directions, evaluate the integral of this unbounded. So we have a constant raised to negative x. So we know that my a is going to be 5, and my b is the number in front of x, so it's indivisible -1. So it's going to be a raised to the bx, so it's going to be -1x over b, which is -1, times ln of a, which is 5, plus c. And then that simplifies as, oh, my a is 5, so put 5 here. So that's going to be negative. So I'm going to put the negative, I could put this minus right here, and then I could put it in the center or in front of negative 5. And then this is still negative x over ln of 5 plus c. Now, can we simplify this? Yes. You can simplify 5 to the negative x. You can write that as a positive power. That would be 1 over 5 to the x. And then you have this ln a on the bottom. I mean, ln of 5 in the bottom. And then you still have this minus here. And don't forget the plus c. Okay, so your final answer is negative 1 over 5 to the x ln of 5 plus c. Okay, example 4. We have e raised to the 10x dx. So now you're doing the exponential rule. So what is the integration of the exponential? It's this. E to the bx dx equals e to the bx over b ln of e, which is really e to the bx over b plus c. Okay, so my b is, what is my b? My b is the number in front of x, so it would be 10. So it's e to the 10x over b, which is 10 plus c. Okay, so there's your answer. So yeah, later on you'll learn that they really got this by using use substitution, and we'll go over that in another video. Okay, what about 5? So we have to take the integration from 0 to 1 of 2x minus 3 raised to the x plus e to the negative 2x times d of x. So, and have bounded, we have bounded, it's from 0 to 1. So what you could do is we have 3 terms, so we can write out 3 integration rules, right? So this would be 0 to the 1, 2x dx minus the integration from 0 to 1. So I put the minus right here, so I'll put it right here. 3 raised to the x dx plus the integration from 0 to 1 of e to the negative 2x dx. Okay, so we know the integration of 2x is just, it's 2x, and then how do you take, you could take the 2 in front if you want to. I'm just going to bring it down. I know the integration rule is old power plus 1 divided by that power. So 1 plus 1 divided by, what's 1 plus 1, 2. And then the 2's cancel, so you're just left with x squared. Over here, it's going to be minus, and then what's the integration of 3 raised to the x? So it's a constant raised to a power, so my a value is 3. My b value is the number in front of the coefficient in front of that, so you don't see a coefficient, so that means it's a 1. So it's going to be a raised to the bx, so it's 3 raised to the bx, so that's 1x over b, which is 1, and then ln of 3, plus e to the negative 2x of dx. So it's a e raised to the power integration, so my b is negative 2. So it's going to be e to the bx, so that's negative 2x over b, which is negative 2, plus no c's, right? So this simplifies as x squared minus 3 raised to the x over ln of 3. And then this is going to be negative e to the negative 2x over 2. I just put this minus in the center. I could do that. And then we have to do our fundamental theorem. So lower boundary, upper boundary. So you do upper boundary minus lower boundary. So plug in 1. It's going to be 1 squared minus 3 to the 1 of ln of 3 minus e. And then negative 2 times 1 is negative 2. 2 minus bracket 0 squared is 0 minus 3 raised to the 0 over ln of 3 minus e to the negative 2 times 0 over 2. Okay. So 1 squared is 1 minus 3 ln of 3. E to the negative 2 is just negative e to the 2 minus, this is going to be 0. 3 raised to 0 is 1, and then you have a minus, so it's minus 1 over ln of 3 minus negative 2 times 0 is 0, so that's negative e to the 0, just 1 over 2. So if I FOIL out this minus, this is just minus 0. This is negative times negative is 1 over ln of 3. And a negative times a negative is a positive 1/2. So this is going to be 1 minus 3 ln of 3. And this is going to be, oh, this is a minus e negative 2 over 2. And what do you see that cancels? Or so if you clean this up, what can you collect? I can collect this and this because they're like both have a ln of 3. So what's negative 3 plus 1? Negative 2 of ln of 3. And then what's 1 plus 3/2? That's positive 3/2. And then you have this negative 1 over 2 e to the negative 2. And that's it. Okay, let's move on to example 6. So what is the integration from 0 to 2 of 7x minus e to the 3x plus square root of x of d of x? So we have boundaries and we have 3 terms. So we can just take the integrations. You can write it as 3 different integration, right? So, or we could just take the derivative, the integration all at once. So if you want, you can do that. What is the integration of 7x? It's a constant raised to the x. So my a is 7 and my b is the number in front of the x. So that would be 1. So that's going to be a raised to the b of x. So it's 7 raised to the b. So that's 1x over b times ln a. So it's 1 times ln of 7. And you know what? Let's just, you don't get confused. Let's write it out. Also, maybe if we, to make it easier, square root of x, we're probably gonna have to use the power rule. So how do you write square root of x as a power x to the 1/2, right? Okay, so we did this part. Now let's do this part. So it's e raised to the b of x. So my b is 3. So it's going to be e to the b, which is 3x, over b, which is 3 over b, right? And then there's a minus, and then plus. What is the integration of x to the 1/2? It is, so it's whole power plus 1. So 1/2 plus 1, which is 3/2. So you divide that by 3/2, right? So that let's clean this up first. So this is going to be x, and then 1/2 plus 2 over 2 is 3/2 divided by 3 over 2, cross multiply, so that's 2x to 3/2 over 3. Okay, so we get 7x over ln of 7 minus e to the 3x over 3 plus 2/3 x to the 3/2. And then we're going from 0 to 2. So this is going to be 7 square. So you do upper boundary minus lower, 7 square ln of 7 minus e 3 times 2 is 6 over 3 plus 2/3 of 2 raised to the 3/2 minus bracket. And then this would be 7 raised to the 0 of ln of 7 minus 3 times 0 is 0, so I'll just do that. Plus 2/3 of 0 raised to the 3/2. Okay. So clean this up. 7 squared is 49 of ln of 7 minus e to the 6 over 3 plus, let's just leave that as it is for now. Minus, and then 7 to the 0 is 1 over ln of 7 minus e to the 0 is 1/3 plus 2/3 times 0 raised to 3/2 is 0. Okay, and then I would just FOIL out this minus, so this is negative 1 over ln of 7. Over here, 2 negatives becomes a positive, so that's 1/3. Over here, this is just going to be 0. So this is going to be 49 over ln of 7. This can be expressed as negative 1/3 e to the 6, and then this thing right here would just be the same. Okay, and then what I would do next is collect like terms. So you can collect this and this because they both have an ln of 7 on the bottom, so they're like the same base. So all you gotta do is do 49 minus 1, which is 48. And then you have this negative 1/3 e to the 6 plus 2/3. I just leave it as it is for now. And then plus 1/3. So you can leave, this would be exact value. If you want it as a decimal, go ahead and put that in the calculator. But I'm just going to leave it as exact value for right now. So yes, this can actually be a number. Okay, let's move on. So example 7 through 10, it says evaluate the integral. So we have integration of 4x minus 1 all over x of d of x. So what I would do is maybe like divide each term by x, right? So this could be like 4x over x minus 1 over x of d of x, correct? And then what happens? The x cancels. You're left with 4 minus 1 over x d of x. And now we can just take the integration individually. So you can break it into two different intervals. So it'd be 4 of d of x minus, so I'm just putting the minus in the middle, of 1 over x d of x. And our final answer will have a plus c because we don't have any bounds. So what is the integration of 4 of dx? So it's going to be 4x. And the reason why is because you're using, so yeah, the integration of a constant, you just add an extra letter of whatever your power is. So we are taking it in respect to x. That's why I use an x. Minus, what is the integration of 1 over x? Do not use the power rule. Do not convert it to x to the -1 and then add 1 over whatever that power, because n cannot equal to -1 if you use this rule. But it's a special one. We know that the integration of exactly 1 over x is ln of absolute value of x plus c. So this is going to be minus ln of absolute value of x plus c. So this is going to be 4x minus ln of absolute value of x plus c. Okay, so that was that one. Let's move on to the next one. So we have the integration of 2 over x of d of x. So the first thing I notice, you have a constant 2. So I'm going to take that out, put it in front of the integral, and then now you have this invisible 1, so it's 1 over x of d of x. And what is the integration of 1 over x? Yes, it is the absolute ln of absolute value of x. And then bring down this 2. Because we have no boundaries, we're going to do a plus c. Okay. Next one, example 9, we do have boundaries from 1 to 2. So it's x squared minus 1 all over x of d of x. So first, what can I do is maybe like divide each term by x. So this would be like x squared over x minus 1 over x of d of x. This is going to be 1 to 2. What's x squared divided by x1? Yes, x minus 1 over x of d of x. So you can write it out as two separate integrals, or you could just take the integration immediately. So I'm just going to take it immediately. So what is the integration of x? Well, this has a power of 1, so it's just 1 plus 1 over 2 minus, what is the integration of 1 over x? It's the ln of absolute value of x. And then over here, this simplifies as 1/2 x squared minus ln of absolute value of x. And then we do the boundaries from 1 to 2. Okay, so we apply fundamental theorem. So you do upper minus lower. So this is going to be 1/2 of 2 squared minus ln of absolute value of 2 minus bracket, and then do the lower boundary. So it's 1/2 of 1 squared minus ln of absolute value of 1. Bring this up. 2 squared is 4. 2 squared is 4 times 2. 2 squared is 4 divided by 2, that's 2, minus ln of absolute value of 2 minus 1 squared is 1 times it by 1/2, that's 1/2, minus ln of 1 which is really just 0. Okay, so this is going to be 2 minus ln of 2. Well, I know that the absolute value 2, so I don't have to put that absolute value. And then FOIL out this minus, so this is negative 1/2. And then this is 0. Collect like terms, so what's 2 and a negative 1/2? That is positive 3/2 minus ln of 2. Okay, that's your final answer. Number 9. Okay, the next one, example 10. So the integration from negative e squared, which is more negative than negative e, right? Or negative e to the 1. So of 3 over x of d of x. So 3 is a constant, so you could take that out. Then you put a 1, and then that just becomes 1 over x. And it's negative e squared of d of x, right? Well, I know the integration of 1 over x is ln of absolute value of x. And then we just do our boundaries. Oops. Wait, so this is negative e squared, and then this is negative e to the 1. Okay, so do the upper minus lower. So this is an upper. Minus bracket ln of absolute value of negative e squared. Okay. So what do I know? What do I know? So ln of e is, oh, and then what did I messed up? What do you see the mistake? I didn't bring down this 3, so it's going to be 3 ln of absolute value of x from the boundaries negative e squared, negative e to the 1, right? Apply your upper boundary, so it's 3 ln of negative e to the x minus bracket 3 ln of absolute value of negative e squared. And what we know is the absolute value of negative e is e, right? The absolute value of negative e is e, so it's going to be 3 ln of e minus 3, and then the absolute value of negative e squared is just positive e squared. And else do we know? We know that ln e are inverses, so that cancels or just becomes 1. So what's 1 times 3? 3. Now, what about here? We have a 3 ln of e squared. Now, we can't just cancel it because of this 2. Well, what do we do? What do we do when we have a power when we're trying to expand? What do we do with the power? We put it in front of the natural log. So it would be 2, and then you still have this 3, and then ln v, right? Well, now you can cancel ln e because now that those are inverses, or it just becomes 1. So you have 1 times 2 times 3, which is 6. And then you have a minus here, so bring down that negative. And then over here, this is 1 times 3, which is 3. And what is 3 minus 6? Yes, you said it, negative 3. Okay, let's move on to 11. So we have the integration of 4 over t minus 6 over t squared of dt. So the first thing I'm going to do is I'm just going to break it down into two separate intervals. It's going to be 4 over t dt minus the integration of 6 over t squared of dt. Okay, let's look at this. What can we do here? I know 4 is a constant. I could just factor that out. So this is 1 over t dt minus the same thing with here. This 6 is a constant, so you could just take out 6. And then this is 1 over t squared dt. And then what's the integration of 1 over t? It's ln of absolute value of t. And then bring down this 4 minus 1 over t squared. What can I do? It's not, if it was 1 over t, it would be the absolute value, ln of absolute value of t, right? And it's not. It has a power of 2. So what I'm going to do is rewrite it as 2t to the negative 2 of dt. And then you just add the power. So negative 2 plus 1 is negative 1. So that's t to the negative 1 over negative 1. T to the negative 1 is 1 over t. And then you have this minus. And yeah. Also, then you have this extra negative 6, right? Because we took out 6 here, and then we have this minus. So a negative and a negative is positive, so it's 6. Positive 6 over t. And then you have 4 ln of absolute value t, right? And because we have no boundaries, it's just plus c. So your final answer is just 4 ln of absolute value t plus 6 over t plus c. Okay, the next one is the next one is this one. So we have the integration from 0 to ln of 2 of 3e to tw. So what I do? Well, I could take out this 3 if I want to, right? So you have 0 and then ln of 2, and then you have e to the 2w. Then what I could do is, so we're taking the integration of e raised to the 2w. So that is going to be, so what you need is your b. So your b is the coefficient in front of the letter. So our b is 2. And so it's just going to be e raised to the bx. So my b is 2x. And then it's all over b, which is 2. And then because we took out a 3, so put a 3 here. And now we do our fundamental theorem. So it's going to be lower and upper, right? So do upper minus lower. So it's going to be 3e 2, and then x is ln of 2 over 2 minus bracket. This would be 3e, and then 2 times 0 is 0 over 2. And then this is going to be 3 e, and then this is going to be 2 ln of 2 over 2 minus 3. E to the 0 is 1 over 2. And then what we're going to do next is what we'll do. So what about here? We have 2e raised to the 2 ln 2. So this is expanded. What if I want to condense it? So remember your log rule, if you want to condense it, you have a number in front of the log or natural log. That number is a power, right? So it would be 3e ln of 2, and then this number is a power, so it's going to be 2 squared all over 2 minus 3 halves. And then this simplifies as, so what happens here? E and ln are inverses, that just becomes 1. So you're left with 3, and then you're also left with this 2 squared doesn't go away. So 2 squared is 4, and then on the bottom is 2 minus 3 halves. And 3 times 4 is 12 over 2 minus 3 halves. And then 12 halves is 6 minus 3 halves. And simplifies as 2 times 2, so that's 12 minus 3, which is 9 halves. Okay, last one. So let's do 13. Integration of 1t square root of e of 4 over n of dn. So 4 is the constant, so take it out. You have a 1, and then the square root of e, and then this is 1 over n dn. So what is the integration of 1 over n? It is ln of absolute value of n. And we have to bring down this 4. And then we do fundamental. So 1 square root of e. We do upper minus lower. So it's going to be 4 ln of square root of 2 minus bracket 4 ln of 1. And I know the absolute value square root of 2 is positive, so you don't, I could just say 4. Oh, I'm bad. This is not, why did I say square root of 2? It should be e, right? And then I know the absolute value of e, square root of e is just positive square root of e minus 4. And then I know that ln of 1 is 0. So yeah. Now, I want to somehow get rid of the ln e because there are somehow inverses, but the thing is, there's a square root. So what I'm going to do is rewrite the square root as a power. So this could be expressed as 4 ln of e to the 1 half. Okay. And what happens when you have, what happens when you have a power, and you want to expand, that power goes in front of the log or natural log. So this would be 4 times 1 half of ln of e minus 0. We know that ln of e cancels, and then 4 times 1 half is 2. And that is your final answer. Okay, so that was 13, and we're going to stop here.